Hello, classmates. Welcome to the course Food Quality Management. Quality is the lifeline of food enterprises. It is also an important foundation for food safety. In enterprise production, quality management cannot rely solely on empirical judgment. We cannot wait until the product has problems before taking remedial measures. And we need to rely on real and accurate quality data. Monitor and analyze the production process. You could say, data is the eye of quality management. In this class, we will focus on classification and nature of food quality data. Clarify the characteristics and application scenarios of different data. Lays the foundation for subsequent learning of tools, such as control charts, histograms, and Pareto charts. First, we ponder a question. Why should we classify food quality data? In the process of food production, processing, inspection, packaging, and storage and transportation, enterprises collect a large amount of data. For example, the production of beverages requires testing for sugar content, acidity, pH value, and filling temperature. When processing meat products, attention should be paid to moisture, salt content, and core temperature. The production of pastry requires recording of net content, baking time, and microbial indicators. In the packaging process, issues such as defective sealing, incorrect labeling, and damaged packaging should also be recorded. These data are all related to quality, but their natures are different. Some data comes from instrument measurements, can include decimals. Some data comes from manual statistics. It can only be an integer. Some data reflects the level of product quality. For example, whether the water content is stable. Some data reflect the frequency of quality issues. For example, how many bags are leaking in a batch of products? If data types are not distinguished, if one cannot choose the correct statistical method, it is also difficult to judge whether the production process is stable. Therefore, data classification is not a simple concept of memorization. It is the first step to carry out quality judgment, quality control, and quality improvement. In quality management, the core classification of quality data is measurement value data and count value data. The measurement value data is a continuous numerical value obtained through measurement. It can usually be accurate to the decimal point. It can reflect the specific degree of quality characteristics. Common measurement data in the food industry include beverage sugar content, milk fat content, meat product moisture content, edible oil acid value, sample pH value, sterilization temperature, refrigeration temperature, net product content, material flow rate, packaging seal strength, etc. This type of data is generally obtained through detection by instruments and equipment, such as electronic balance, pH meter, refractometer, thermometer, colorimeter, texture analyzer, and chromatograph, etc. The advantage of quantitative data lies in its ability to reflect subtle changes, suitable for process monitoring. For example, the sugar content standard for a certain beverage is 10 degrees Brix. The test results may be 9.8, 10.0, or 10.2. The individual results all seem to be close to the standard. But after continuous recording, you can determine whether there is a trend of gradually increasing or decreasing sugar content. Thus, issues related to ingredient, mixing, or equipment control can be identified in advance. Another example is the storage temperature of cold chain food. If we only look at whether a certain attempt is qualified, the risk may not be identified, but continuously recording temperature changes, we can determine whether the refrigeration system is stable. Thus, it can be seen the measurement data not only tells us whether it is qualified or not, it also tells us how much deviation how big the fluctuation is, and what the trend is. Count value data is discrete data obtained through counting. Only integers can be taken. It cannot be infinitely subdivided. It is mainly used to record the number of non-conforming products, the number of defects, the number of complaints, and the number of contaminated colonies. For example, out of a batch of 100 bags of products, 3 bags have poor sealing. Here, 3 bags is a count value. There are 2 cracks on the surface of a piece of pastry. The 2 minutes here is also a count value. It focuses on the frequency or quantity of quality issues that occur, rather than the specific measurement level of a certain quality indicator. Count value data can be further divided into piece rate value data and point value data. These 2 concepts need to be distinguished. The piece rate data is based on the number of product pieces as the statistical object. The core is to determine whether each product or sample unit is qualified. That is, we should focus on how many products are unqualified. For example, a batch of canned goods was sampled and inspected, with 200 cans being examined. Among them, 6 cans failed the vacuum test. A batch of bagged food products was sampled and inspected, with 100 bags examined. Among them, the net content of 2 bags is insufficient. A batch of 50 bottles of beverage was sampled for inspection. 1 bottle has a wrong label. These all belong to piece rate value data. The piece rate value data is commonly used for product batch release, sampling inspection, and quality judgment. The focus of analysis is on the number of non-conforming products, the rate of non-conforming products, or the pass rate. The result is intuitive. It facilitates management decisions of qualified or unqualified. The point value data is based on the number of defects as the statistical object. Pay attention to how many defect points appear in a product, a region, or a unit sample. It does not necessarily directly judge whether the entire product is qualified. Instead, more attention is paid to the defect density and distribution pattern. For example, there are 3 printing stains on the surface of a certain packaging bag. There are 2 scratches on the appearance of a certain bottled product. A certain number of bacterial colonies were detected in a certain food sample. During a hygiene inspection of a certain production area, 5 issues of inadequate cleaning were identified. All of these can be classified as point value data. Through the point value data, the enterprise can analyze the source of defects, conduct a preliminary investigation into potential quality and safety risks. Next, we make a comparison among 3 types of data. The measurement data is continuous. It can include decimals, reflect the specific level of quality characteristics, such as pH value, moisture, temperature, and content. The piece rate data is an integer. Count the number of qualified or unqualified products. Reflects the conformity of the product. The point value data is also an integer. But what is counted is the number of defects or problem points. Reflect the frequency and distribution of defects. From the perspective of application scenarios, the measured values are suitable for rationalization index detection and process parameter monitoring. The piece rate value is suitable for batch determination and sampling inspection. The point system is suitable for defect analysis, hygiene monitoring, and process improvement. From the perspective of analysis tools, measurement values are commonly used in mean range control charts, mean standard deviation control charts, and process capability analysis. The piece rate value is commonly used in non-conforming product rate control charts. The point system is commonly used in defect number control charts. Different data correspond to different statistical logics. It cannot be mixed arbitrarily. Here, I would like to remind everyone in particular, data type judgment error. It will directly affect quality decisions. For example, analyze the quantity of non-conforming products as continuous measurement data. It may lead to incorrect fluctuation judgments. Convert quantitative values such as pH value and moisture content into simple categories of qualified or unqualified. A lot of process change information will be lost. Quality management emphasizes scientificity and normalization. The first step is to respect the nature of the data itself. Through the study of this lesson, we can see that although food quality data comes in various forms, but basically, we can distinguish between obtained through measurement and obtained through statistics. The continuous numerical values obtained through measurement. It is mainly quantitative data. The integer data obtained through statistics. It is mainly count value data. In the count value data, if the statistics are based on the number of non-conforming products, it refers to the piece rate value data. If the statistics are on the number of defective points or problem points, it is point value data. These two major types of data together constitute the food quality monitoring system. Measurement data helps enterprises grasp the stability of physicochemical indicators and process parameters. Count data helps companies identify non-conforming products, defects, and quality risks. An abnormal temperature record. It may indicate insufficient sterilization. The rate of non-conforming products increases. It may indicate deviations in equipment or operation. An abnormal number of microorganisms was observed. It may expose to risks of cleaning and disinfection or cross-contamination. Therefore, food quality management is not trivial. Every data item bears the responsibility for security. Finally, please remember the key conclusion of this class. The measurement value depends on the degree. The count value is based on quantity. The piece rate value is number of products. The point value is defect points. After mastering this foundation, when we learn about quality management tools in the future, we can then select methods and interpret results more accurately, and gradually develop a quality management mindset that utilizes data to identify, analyze, and solve problems. Lay a solid foundation for future work in food production, testing, and quality management.